Hello again. In this video, we're going to talk about orthogonal vectors. The definition of two vectors that are orthogonal to each other, u and v in Rn. Hello again. In this video, we're going to talk about orthogonal vectors. The definition of two vectors in Rn are orthogonal to each other if their dot product is equal to 0. And the theorem that naturally arises from this is the Pythagorean theorem, which we have seen in the past in R2. Two vectors u and v are orthogonal if and only if u plus v, the length of that squared, is equal to the length of u squared plus the length of v squared. So you can see that is the Pythagorean theorem, because if you look over here, if you call this u and you call this v, you can see here that the c is like a squared plus b squared is equal to the c squared. To prove this, we're going to look at the following. Two lines shown in this figure are geometrically perpendicular to each other if and only if the distance of u minus v, the length of u minus v, is equal to the length of u plus v, which is right here. You can see here if they were not orthogonal, if they're not perpendicular, then here would be u minus v, and here would be u plus v. Right. And you can see they would not be the same. So let's go ahead and erase that. And go ahead and write it down what these are. If we look at the length of u plus v squared, we know that the definition is u plus v divided with u plus v. And if I expand that out, I get the length of u squared plus 2u divided with v plus the length of u squared. And that gives us this way, doesn't it? If they're orthogonal, we know that the dot product is 0, and so we have it. To go the other way, I'm going to look at the length of u minus v squared, which is a very similar situation. And actually, I'm going to do it both at the same time. So two lines are perpendicular to each other, we know from geometry, if and only if this distance is equal to this length is equal to this length in R2, which is the same thing if I square both sides. And we found the distance of those, and I did notice a mistake here. This was supposed to be a v. And then we end up crossing everything else out, bringing this over. We get 4u dot v is equal to 0, so u dot v is equal to 0. So now we have two lines are perpendicular to each other if and only if u dot v is equal to 0. We have both ways for R2 and actually for R3 as well. But it actually works for any u and v in Rn. There's a special formula that only works in R2 and in R3 for u dot v. U dot v is the magnitude or the length of u times the length of v times cosine of theta. And you can see when theta is 90 degrees, u dot v would be equal 0. So it does look like a reasonable formula. But how they proved it is they looked at u minus v, the magnitude of that, which is, here's u, here's v, and by the law of cosines, if you remember, from trigonometry, c squared equals a squared plus b squared minus 2ab cosine of theta. And this is our a, and this is our b, and this is our C. So you just have that there. And then solving for cosine of theta here, or actually solving for this term, you can bring this over, bring that there, divide by 1/2. And if you expand this out, we know that that is u1 squared plus u2 squared. Same with that one. And then this one would be u minus v1 squared plus u2 minus v2 squared, but with a minus sign in both. And if you multiply that out, you're just going to get this. You can see if you expand this out, you get this, but making sure you put a minus through everywhere. And then this would be this one. And you cancel all the u squares, and the v1 squares and the v2 squares will all cancel, giving you this. So you end up with this, which is u dot v. The verification for R3 is very similar, but it only works for R2 and R3. So let's try these practice problems. It says, determine which pair is orthogonal. So you have a couple ways to doing it. So first of all, number 15. We can look at the Pythagorean theorem. So in our case, we have a's and b's. So if I take a plus b, what would that be? Let's square it. That would be, we could use the Pythagorean theorem because we know that this is true if and only if a and b are orthogonal. So if I look at the length of a plus b squared, I get 10. The length of a is square root of 89, and the length of b 13. So if I add those together, I do not get 10. So this is not orthogonal. Just can put a not here, and we can say since. Or we could do the dot product. Let's do number 16 with the dot product. This one is yes. Oh, what was this? That got erased. Oh, maybe it didn't. This is orthogonal since I looked at the dot product. U dotted with v is u transform times v, which is 24, negative 9, and negative 15 does add up to 0. So yes, this is orthogonal by the definition. By the way, if you looked at the dot product here, you can see negative 16 and 15 does not add to 0. And that is it for this video.